Welcome to my lecture. Today I will discuss about numerical analysis, and I will begin my lecture by defining what is interpolation and extrapolation. So first, I want to say what is numerical analysis. So in numerical analysis, we generally discuss the methods about how to solve various numerical problems, such as a solution of a system of linear equations, then an algebraic equation. So we discuss all these methods in numerical analysis, and moreover, we discuss about its stability and error analysis, propagation of error, etc. So the subject numerical analysis is a vast subject which has direct application in the solution of various equations. Particularly in research activities, many a time we have to face some equations, particularly the differential equations, or say partial differential equations, or a system of linear equations. So this can be solved only through numerical analysis. So that's why the importance of numerical analysis is immense. And we begin my course lecture by defining interpolation. So what is interpolation? So interpolation is defined as a process of computing the intermediate value of a function from a given set of tabular values of that function. Means that, say, if we have given a set of numbers, say y0, y1, y2, up to say yn, then we can determine an intermediate value, means that a value which lies in between y0 and yn. So similarly, extrapolation is defined as a process of computing the value of a function from a given set of value which lies outside the range of the tabular values of that function. Means that, say, we have these values y0, y1, y2 up to yn. Then we can calculate the value, say, yn plus 1 by using this interpolation. Say we have to compute the population of India in the year 2030. Then we have to apply the process of extrapolation. And say in between, say we want to determine the population of India in 2021, then we can use the concept of interpolation. So next, I will define some operators. This is the difference operators. Say it is denoted by delta, then it is read as delta, and say delta square, delta cube, etc. So then what is say delta naught? So delta naught is defined as y1 minus this y0. Similarly, I can define this delta square y0, delta square y0 equal to delta y1 minus delta y0. So then I can now put the value. What is delta y0? Delta y1. First I will put the value of delta y1. So means that this is equal to y2 minus y1. Then minus this is y1 minus y0. So after simplification, I will get this is y2 minus 2y1 plus y0. So in this way, I can compute this delta cube y0. And moreover, you see there is a pattern of the coefficients of delta square y0. In the expanded form of delta square y0, we see that it is y2 minus 2y1 plus y0. Here the coefficients are placed in symmetry. So the coefficient of y2 is 1 and coefficient of y0 is 1 and middle term is 2. So in that way, I can compute immediately that the delta cube y0. So then delta cube y0, say delta cube y0 equal to, then I can write this is y3 minus 3y2 plus 3y1 and minus y0. So again, these are placed in symmetry. You see, so it is the coefficient of y3 is 1, y0 is 1, and the middle terms are 3. And these are actually the binomial coefficients of expansion. So in a binomial expansion, the coefficients are placed in symmetry. So this is in the same way. So immediately I can write then similarly then delta to the power 4 y0, and the coefficients will be as that of this binomial expansion. So next, sometimes we see that a function, say f of x is there, and the form of the function, say, may not be known sometimes, or sometimes it is very difficult to handle it because we do not know the, say, form or, say, structure of the function. But we can replace this function fx by another polynomial. And what is the justification of replacing this function fx by another polynomial? And this is given by a mathematician Strauss in the year 1885. So he postulates two theorems on which we can replace this function by a polynomial. And the first postulate is that any function which is continuous, in an interval, say a comma b, can be replaced by another polynomial px, means that fx was a given function. Now we can replace this function by a polynomial px, provided the modulus of this is less than epsilon. So in that interval. And what is epsilon? So epsilon is a pre-assigned quantity, means that we will assign this quantity. So what will be our tolerance of error? Means that if the difference between fx and px is less than the prescribed quantity, for example, I can say that epsilon may be equal to, say, 10 to the power 5, 10 to the power minus 5, or say 10 to the power minus 9, means that it is of nanoscale. So then this depends on our physical situation, how we define this epsilon. So therefore, a function fx can be replaced by another polynomial px, provided the modulus of fx minus px is less than epsilon, and epsilon will provide it. And the second postulate is that a function of period 2 pi, can be represented in the form of a trigonometric series, that is px equal to this is a naught plus a1 sin x plus a2 sin twice x plus this is an sin n x plus a cosine series, say this is b1 cos of x plus b2 cos of twice x plus the last term, this is bn sin of cos of bn cos of nx. So based on these two theorems, a function can be replaced by a polynomial. Now I shall define two difference tables. So one is horizontal difference table, another is diagonal difference table. And the diagonal difference table is used for determining the value of a function which lies in the middle of the given values of that function. Means that we can use this table for doing interpolation. And the horizontal difference table is used to compute the value of a function in the case of extrapolation. So let us consider there is a function fx y equal fx, and it takes the values, say y0, y1, y2 up to yn. For the corresponding argumental values x0, x1, x2 up to xn of the independent variable x. Means that y is a dependent variable and x is the independent variable and f is the rule by which we are associating these values. Now I can define the diagonal difference table. say these are the values of x. It takes the values, say x0, x1, x2, say x3. I am writing just 4 values. And the corresponding values of y equal to, say, y0, this is y1, and this is y2, and this is y3. And these are values of y. Now I will obtain the first difference. So then the value y1 minus y0 is equal to the delta y0. And this is written in between y0 and y1. Means that I will write the value of delta y0 in between, in the middle of y0 and y. So then I am writing this is y1 minus y0. So this is equal to delta y0. Similarly, y2 minus y1. So this is equal to delta y1. And y3 minus y2 equal to delta y2. Again, the difference of the first difference is the second difference. So this is denoted by delta square y. And this is delta y1. Delta y1 minus delta y0 equal to delta square y0. So similarly, delta y2 minus delta y1 equal to delta square y1. And finally, it is then delta cube y. And this is the difference between delta square y1 and delta square y0. So then this is delta square y1 minus delta square y0. And this is denoted by delta cube y0. Now you see, here the values goes in a diagonal way. Because I am writing the value of delta y0 in between y1 and y0, that is at the middle of this y1 and y0. So therefore, it goes in a diagonal way. That's why the name is the diagonal difference step. And already I have said that this delta cube y0 we can compute by putting the binomial coefficients. Because this is in a symmetric way, means that delta cube y0 equal to y3 minus 3y2 plus 3y1 and plus y0. In that way we can compute it. Moreover, there is another formula for computing the value of this delta to the power n y0. So this formula here I am to mention it. So this formula is then e to the power n y0 equal to yn. So by this formula we can compute the other higher differences of this delta cube y0. Next then I will show you the horizontal difference. Again, let us consider y equal fx be a function which takes the values y0, y1, y2 up to yn for the corresponding argumental values. This is x0, x1, x2 up to xn of the independent variable x. Now we can construct the horizontal difference. So these are the values of x and this will be the values of y. Again I am taking 4 values, x0, x1, x2 and x3. So corresponding values are y0, y1, y2, y3. Now here the values written parallel to say second value, means that I will write the value parallel to y1 and next then parallel to y2, then parallel to y3. So then I am writing this is y1 minus y0. And here the suffix is written as a subscript, not as that of earlier as a superscript. Now I will write this y1 minus y0 is equal to, it is a delta 1, this is then y0. Similarly, this is y2. It is written as y1 minus y0 equal to delta 1 y1. Similarly, y2 minus y1 equal to delta 1 y2. y3 minus y2 is equal to then delta 1 y3. So this difference is denoted by delta 1, this subscript, and then y. Next, I will define this delta 1 y2 minus delta 1 y0. Sorry, delta 1. So this is equal to delta 2, the subscript delta 2, and then this is y2. Similarly, this is delta 1 y3 minus delta 1 y2. So this is equal to delta 2 y3. Delta 2 y3. So this is denoted by, this is delta 2 y. And finally, the difference between this is delta 2 y3 minus delta 2 y2. So this is equal to delta 3 y3. So then here it is delta, this is 3y. So if we have 4 entries, means that if we have 4 values, then we will get these 3 differences. So in general, so if we have then n values, then we will get n minus 1 differences. So if we have n plus 1 values, say if it goes from say y0 to yn, then we have this n plus 1 values, and then in that case we will have n differences. So this is all about this horizontal difference table, and this table is used for doing interpolation. With this, I have defined first interpolation, then extrapolation, and then I have stated the 2 theorems of stress and 2 difference tables. One is the diagonal difference table, another is the horizontal difference table. And the diagonal difference table is used for doing interpolation works, and this horizontal difference table is used for extrapolation works. So next we will discuss the Newton's forward interpolation formula as well as the Newton's backward formula. So it will be in my second part of my lecture. Thank you. So, hello.